Hello, this is Dr. Hanaa Assil, and this is paper 1CR of January 2020 in the Pearson Edexcel IGCSE for chemistry. So let us take a look at the first question and discuss the answers. The diagram shows the particles in the atom of an element. Now, particle Y is a proton. So what is particle Z? You can see that particle Z is the other particle in the nucleus. So what do we have in the nucleus? We have proton and neutron. So Z is a neutron. Which of these has the smallest mass? You should know that in the atom, the electron has the smallest mass. We say that the mass of an electron is about 1/1840 or 1/2000, while the proton and neutron are given a mass of 1. What is the mass number of this atom? How do we get the mass number of an atom? It is the total of the particles inside the nucleus. So how many total particles, protons plus neutrons, inside the nucleus? We have 9 particles in the nucleus, so the mass number is 9. What is the atomic number of the atom? What do we mean by atomic number? Atomic number is the number of protons. So how many protons do we have? He said Y is the proton, and that's the white ball in there. So we have 4 protons. So the atomic number is 4. Identify the element that contains this atom. So if the atom has 4 protons, atomic number 4, you look at the periodic table for what has atomic number 4 or small number 4 in the periodic table. That will be beryllium. State what is formed when this atom loses its outer shell electrons. Remember, if an atom loses the outer shell electrons, then it becomes a positive ion, because in that case, remember, an atom has equal number of protons and electrons. But if it loses any of its electrons, then now it has extra protons that have a positive charge, so you have a positive ion. This question is about states of matter. The diagram shows how the particles of a substance are arranged in 2 different states. So he draws the particles for a solid and the particles for a gas. And he's saying complete the diagram to show how particles are arranged in the liquid. How would you draw these particles in a liquid? Remember, in a liquid, some of them should be touching, some of them not touching. So this is random arrangement near to each other, and they should fill the bottom part of the container. Identify the state of matter in which the particles have the most energy. Which of these has the most energy? You should know that solid particles have some energy, so they just vibrate in their fixed position. The liquids will have more energy, so they slide over each other. And gases are the ones that have the most energy, so they move in a fast, free, random motion. The state symbols, these are often used in chemistry. The table shows some physical changes. Complete the table by giving the state symbols before and after each change. So when he says water evaporates, water originally is what? It's a liquid, and when it evaporates, it becomes a gas. So you want to write the state symbols. Don't write liquid or gas. It is L and G. Crystals of iodine sublime. Crystals at the beginning are solid. Now, sublimation means they change from solid to what? To gas. So when it sublimes, it changes into gas. Now, when ice melts, ice originally is what? Ice is a solid. When it melts, it becomes water, which is a liquid. Okay? Explain how hot water evaporates more quickly than cold water. Why hot water evaporates more quickly than cold water? Remember, when you have evaporation, what is evaporation? The particles need energy to move faster, overcome the attraction forces between them, and then escape out of the liquid or move further apart so that they evaporate. So when the water is hot, the particles have more kinetic energy, move faster, and are able to overcome the attraction forces between them, so they will evaporate more quickly. Okay? Group 7 elements are called halogens. Halogens form compounds called halides. So we have chlorides, bromides, iodides, and so on. 3 of the halogens are represented by the formula X2, Y2, and Z2. Solutions of these halogens are added separately to solutions of sodium halides, sodium with X, sodium Y, and sodium Z. The table shows whether or not a reaction occurs. Remember this kind of experiments. What do we do? If X2 reacts, for example, with, so if in this table X2 does not react with NaY and it does not react with NaZ, that tells me that X2 is less reactive than Y and Z. Now, if I say that Y2 reacts with sodium X, that means that Y is more reactive than X. If we say that Z reacts with NaX, that means Z is more reactive than X. So the arrangement of reactivity, and please notice he's saying start from the most reactive or from the less reactive. So Z was able to react with NaX, and that means it is more reactive than X. And it was able to react with NaY, and that means it is more reactive than Y, so Z is the most reactive. And then Y was able to react with NaX, that means Y is more reactive than X. So this is the arrangement of reactivity. Remember that this happens with halogens and this happens with metals, of course. The one that reacts with the salt of the other, then that metal is the more reactive. An aqueous solution of halogen Y2 is orange. Now, you should know that halogens are what? Fluorine, chlorine, bromine, iodine. Which of these is orange anyway? Without any other information, you should know that bromine is the one that is orange. This solution is decolorized when it reacts with an alkene. So that confirms that we're talking about bromine, because bromine is the one that reacts with alkenes and becomes decolorized. So identify halogen Y2, that is bromine. So remember that bromine, first of all, bromine is the only liquid non-metal. It is what color? It is orange, or sometimes we refer to it as reddish brown. And it reacts with alkenes and becomes decolorized or changes from orange to colorless. The table shows some physical properties of halogens. Complete the table by predicting boiling point for chlorine, state of fluorine at room temperature, and color of astatine. So let's start with fluorine. What is the state of fluorine at room temperature? You should know that fluorine is a gas. Now, chlorine, what do you think would be its boiling point? Well, its boiling point is anything between 59 to minus 188. So something in between could be around, for example, minus 100. Usually there is a range that can be accepted. And the astatine, what is the color of astatine? You should know that the color of astatine is black. Remember that the color, as we go down group 7, it gets darker. So fluorine is yellow gas, chlorine is green gas, bromine is reddish brown liquid, iodine is a gray solid, so astatine is a black solid. Why do the halogens have similar chemical properties? Remember that all halogens are in the same group. They're all in group 7. So they all have the same number of electrons in outer shell. Remember, they don't have the same number of shells. They have the same number of electrons in outer shell. A teacher uses this apparatus to demonstrate the reaction between chlorine gas and iron wool. The teacher does the reaction in a fume cupboard. So she's passing chlorine over iron wool and the unreacted chlorine goes from the other side. Suggest why the teacher does the reaction in a fume cupboard. Remember that any reaction that involves gases in general should be done in a fume cupboard, especially if we're working with chlorine because chlorine gas is toxic or poisonous. The product of the reaction between iron and chlorine is iron 3 chloride. The ions in iron 3 chloride are these. Use this information to give the chemical equation for this reaction. I'm reminding you again, chemical equation means symbol balanced. So what are we reacting? We're reacting iron with chlorine. Remember that chlorine is diatomic, so chlorine has to be Cl2 to give iron 3 chloride, and then we cannot leave it like this. We have to balance. So if we balance, you'll find that we need 2 iron before the arrow so that I can have 2 iron after the arrow in order to balance the chlorine, so that now I have 6 chlorines after the arrow and 6 chlorines before the arrow. Remember, we multiply 2 times 3. So this is now the balanced equation. This question is about ammonium chloride. Give the formula of ammonium ion. How do we write ammonium ion? It is NH4 with 1 positive charge. Describe a test to show that ammonium chloride contains ammonium ions. What is the test for ammonium ions? Well, let's see. We add what? We add, remember this is for ammonium, not just ammonia gas. Ammonium, I have to add aqueous sodium hydroxide, warm gently. This will give bubbles of gas that turn damp red litmus paper to blue. Okay, remember that ammonium ions react with a base like sodium hydroxide and give out ammonia gas, which turns damp red litmus to blue. The equation shows the thermal decomposition of ammonium chloride. Remember, when we break a substance into 2 or more substances, then this is called decomposition. Using heat, it is thermal decomposition. Now, state what this symbol means. This symbol indicates that the reaction is reversible, or we have a reversible reaction. The diagram shows the formation of ammonium chloride in a glass tube. So he has cotton wool soaked in concentrated hydrochloric acid on one end, cotton wool soaked in concentrated ammonia on the other end. And he's saying, explain how the mean speed of ammonia molecules compares with the speed of the hydrogen chloride molecules. So which one is moving faster? Remember that they both will diffuse. So HCl will diffuse from where there is a lot of HCl to lower concentrations. The ammonia will also diffuse, but which one diffuses faster? Well, obviously they meet to form ammonium chloride, and this is nearer to the HCl, and that means that the particles of ammonia are moving faster. And that is because he's saying explain, that is because the ammonium chloride is formed nearer to the HCl. So I can tell that the ammonia is moving faster. And you should know why is it that the ammonia is moving faster. It is because the particles with lower molecular mass move faster. So ammonia has a total molecular mass of what? 14 plus 3, that's 17, while the HCl has a total molecular mass of 36.5. So the one with lower molecular mass, which is the ammonia, will diffuse faster. Of course, they're moving by diffusion, and that means they meet nearer to the HCl. And when the ammonia meets with HCl, it forms a white solid of ammonium chloride. Gas particles travel very quickly. Give 2 reasons why it takes several minutes for the ammonium chloride to form. If the gas particles are traveling quickly, why doesn't the white solid of ammonium chloride form quickly? This is because the particles are not really moving in a straight line. The gas particles move randomly in all directions, colliding with the air particles. So the particles of the air are delaying the movement of the gas particles, and they collide with the walls of the tube, so they are not moving really directly, and that's why it will take them several minutes in order to meet with the HCl particles. A teacher uses the reaction between phosphorus and oxygen to calculate the percentage of oxygen in air. She uses this apparatus and excess phosphorus. So we have a piece of phosphorus on a wire, and we have a glass tube full of air. So of course there is oxygen, and I have water going up to a certain level in the tube. The volume of gas in the tube decreases because the phosphorus reacts with oxygen. So the water is going to go up to replace the oxygen that is being used. The teacher measures the volume of gas in the tube at 1 minute intervals. So we're measuring the volume every minute. The table shows the teacher's results. So where are the teacher's results? Here they are. State how the results show that all the oxygen has reacted. So we started with a total volume of gas in the tube of 48.5. Now, as the reaction proceeded, the phosphorus is reacting with the oxygen in the air, so we're taking oxygen from the air, so the volume of the air in the tube is decreasing. But how do we know that the reaction has finished or all the oxygen has reacted? Because the volume remains constant at the end. So after 5 minutes, the volume is not changing anymore, and that means there is no more oxygen to react. Give one change to this experiment that would make the results more accurate. Now, the tube had 0.5 divisions, so we can use a tube with smaller divisions. Okay? Use the results to calculate the percentage of oxygen in air. From these results, how do we calculate the percentage of oxygen in the air? Remember that the amount of oxygen is the difference between the initial volume and the final volume. And then to get percentage, we put the difference over the original volume times 100. Remember, he is saying give your answer to what? 1 decimal place, so please make sure it is 1 decimal place. The reaction between magnesium and copper sulfate solution is exothermic. This apparatus is used to measure the temperature increase when excess magnesium is added to 100 centimeter cubed of copper sulfate. So we have 100 centimeter cubed of copper sulfate solution. We're adding magnesium and we're measuring the temperature. State why a reaction occurs when magnesium is added to copper sulfate. Why is it that magnesium reacts with copper sulfate? Of course, we said when a metal reacts with the salt of another one, that is because the magnesium is more reactive than copper, and that is why it is able to displace the copper. So if I react magnesium plus copper sulfate, what is the product? Well, that will give magnesium sulfate plus copper. So the magnesium is more reactive than copper, it displaces the copper. The temperature at the start of the reaction is 20.2 degrees Celsius. The maximum temperature recorded, so the temperature went up to 56.3. Calculate the heat energy change. How do we calculate heat energy change? Remember that heat energy change is Q. Q is equal to mc delta T. You should know this equation. M is the mass of the solution. Remember, he used how much solution? If we go back here, he used 100 centimeter cubed of copper sulfate solution. So my mass is 100 times C, which is 4.2, times delta T, which is the temperature change. So it is the difference between the final minus the initial. And my answer for Q always comes out in joules. Okay? Explain why it is better to use a polystyrene cup rather than a glass beaker in this experiment. Usually, when we do an experiment that measures temperature, we should do it in a polystyrene cup, and preferably that has a lid. Why? Because polystyrene is an insulator, so there will be less loss of heat to the environment. Okay? The reaction between zinc and copper sulfate is also exothermic. A mass of 0.5 grams of zinc is reacted with excess copper sulfate solution. The heat energy changes this. So he already calculated Q and he got that it is 1.67 kilojoules. Calculate the molar enthalpy change. So if I have Q, how do I get delta H? You should know. Delta H is Q over N. So I need to get first the number of moles of zinc. How do we get number of moles? He gives me 0.5 grams. So I'm going to say mass over molecular mass. So that is 0.5 over the molecular mass of zinc. This gives me the number of moles of zinc. So I can use that to get delta H. Delta H is Q over N. So the Q that he gives me is already in kilojoules over the number of moles I calculated. Now this comes out to this number. Why did I put a minus sign? Remember that delta H must have a minus sign. Q doesn't. So when you're calculating Q, you don't put minus or plus. But for delta H, we have to put a sign. Now, how do I know it is a negative? Because up there in that first sentence, it says that the reaction is exothermic. Exothermic means it gives out heat, and that means the delta H is negative. Then I haven't finished. Remember, he says, give your answer to what? To 3 significant figures. So I cannot leave it as it is. I have to put it in 3 significant figures. So my answer is minus 270. The ionic equation for the reaction between zinc and copper sulfate is this. Explain why this is a redox reaction. Again, when he says this question, we need to say because something happened that is oxidation and something happened that is reduction. So in this equation, where is oxidation, where is reduction? The zinc changed to zinc 2 plus. That means it has lost electrons. Loss of electrons is oxidation. Or you can say the oxidation number has increased. So the zinc alone has oxidation number 0. The zinc 2 plus has plus 2 as oxidation number. So the oxidation number changed from 0 to plus 2. That is an increase in oxidation number. That's oxidation. Now, copper 2 plus, what happened to the copper 2 plus? It gained electrons in order to become copper. Or it had a reduction in its oxidation number. Its oxidation number changed from plus 2 to 0. So that is reduction. So I need to say that the zinc loses electrons, and that is oxidation. The copper 2 plus gains electrons, and that is reduction. A student investigates the reaction between sodium hydroxide solution and hydrochloric acid. He uses this method, so he added 50 centimeter cubed of dilute hydrochloric acid to a conical flask, add 5 centimeter cube portions of sodium hydroxide solution to the conical flask, test the pH of the mixture using both universal indicator paper and a pH meter. The student repeats step 2 and 3 until a total of 50 centimeter cubed of sodium hydroxide has been added. So he's just adding more and more sodium hydroxide and measuring the pH. State the piece of apparatus that should be used to measure 50 centimeter cubed of hydrochloric acid. Remember that we don't want it exactly. It doesn't have to be 50.0. So we can use a measuring cylinder. You can also say burette if you want, or pipette if you want, but a measuring cylinder is fine enough. Okay, name the type of reaction that occurs between hydrochloric acid and sodium hydroxide. Of course, acid plus base to give salt plus water, that is neutralization reaction. An acid with a base has to be neutralization reaction. Graph 1 shows how the pH of the mixture changes as the sodium hydroxide solution is added. As he adds the sodium hydroxide, he's measuring the pH. Determine the pH after 40 centimeter cubed of sodium hydroxide solution has been added. So if we look at the graph, this is 40 centimeter cubed. I go up to the graph and I find that it is pH 12.4. So just the color of the universal indicator paper when these volumes of sodium hydroxide solution had been added. Well, when he added 15 centimeter cubed, where is 15 centimeter cubed? The pH was what? The pH was 2, so what would be the color of the universal indicator paper? It will be red. Now, when he added 30 centimeter cubed, where is 30 centimeter cubed? The pH was what? 11. What would be the color of universal indicator paper when it is 11? Blue. Remember that anything below 7 is acid, above 7 is a base. Give the formula of the ion that causes sodium hydroxide to be alkaline. Of course, any solution is alkaline if it has OH minus, the hydroxide ion, OH with a minus sign. Another student investigates how the temperature changes when sodium hydroxide solution is added to hydrochloric acid. The hydrochloric acid and sodium hydroxide solution are at the same temperature at the start of the investigation. The student records the temperature of the mixture after adding each 5 centimeter cube portion of sodium hydroxide, and the graph shows her results. So explain the shape of graph 2. Now, what is graph 2? This is graph. This is the graph. Now, explain the shape. What is happening? He is adding sodium hydroxide solution. At the beginning, the temperature keeps rising until we reach a maximum at 25. Now, adding any more sodium hydroxide, the temperature starts to decrease. And that means that, first of all, the reaction is exothermic. So as it reacts, the temperature rises. The reaction is complete after 25 because adding any more sodium hydroxide causes the solution to cool down. So that is what we can learn from the graph. The diagram shows the arrangement of electrons in an atom of calcium and in an atom of chlorine. Describe in terms of electrons what happens when calcium reacts with chlorine. Remember that calcium has how many electrons in its outermost shell? You can see that it has 2 electrons, or if you look at the periodic table, it has 2, it's in group 2, so it has 2 electrons in its outermost shell. Now, calcium is a metal, chlorine is a non-metal, and that means the calcium will lose its outermost electrons, which are 2 electrons, and that means if I have chlorine in group 7, it has 7 electrons. Each chlorine needs only 1 electron. And that means I will need 2 chlorine atoms to gain 1 electron each in order to take the 2 electrons that were lost by calcium. So remember, the calcium will lose 2 electrons. But each chlorine can take only 1 because the chlorine has 7 electrons in its outermost shell and we need them to be 8. So we need 2 chlorine atoms to gain 1 electron each. Describe tests to show that an aqueous solution of calcium chloride contains calcium ions and chloride ions. So what is the test for calcium ions? Well, we have several tests for calcium ions, but we can say, for example, flame test. Flame test with calcium will give an orange-red color, or what we call a brick red color. What is the test for chloride ions? Test for chloride ions is add aqueous nitric acid, then silver nitrate solution. Remember, this was the test for the halides. I have what? I have chloride, so the chloride would give me white precipitate. If I had bromide, it would be cream precipitate. If it's iodide, it would be yellow. Remember these tests? Okay, Solid calcium chloride does not conduct electricity. Aqueous solutions of calcium chloride do conduct electricity. A student uses this method to investigate how the conductivity of a solution changes when calcium chloride is dissolved in pure water. So we're going to start with 100 centimeter cubed of pure water in a beaker. Add 1 spatula of solid calcium chloride to the beaker. Stir the solution. Measure the conductivity of the solution and repeat with more and more spatulas of solid calcium chloride. The table shows the students' results. So these are our results, and we're supposed to plot the results on a grid. So when you plot the results of that table, you'll find that, of course, we plot with X's. And then he says, remember, when you plot a graph, you have to check, is he telling me to join it in a specific way? He's saying draw 2 straight lines of best fit. And we're going to ignore any anomalous results. So obviously that one that's away from the line is an anomalous result at number of spatulas 3. We join straight line, 2 straight lines, so they have to cross each other, and this would be our graph. State the trend shown on the graph for the first 6 spatulas. What is happening in the first 6 spatulas? Of course, the conductivity increases as the number of spatulas of calcium chloride increases, and it's actually directly proportional. Remember, if we have a straight line going through the origin, that means they are directly proportional. So just an error the student could have made to cause the anomalous result. What do you think happened after he added 3 spatulas of calcium chloride so that he got the wrong result? Well, one thing that he could have done is the fact that he did not stir the mixture. Remember, if he does not stir the mixture, then the reactants will not be equally distributed. Describe another way to make solid calcium chloride conduct electricity. Remember that calcium chloride is ionic. As a solid, ionic compounds would not conduct electricity. And if we say why, because the ions are fixed in a 3-dimensional crystal lattice, so they're not able to move. But in order to conduct electricity, they have to be able to move. So either I dissolve it in water, as he did, to make a solution, or I heat it until it is molten. In that case, the ions will be free to move. This question is about alkenes and polymers. Ethene, C2H4, can be represented by different types of formula. What do we mean by empirical formula? You should remember that empirical formula means the formula using or showing the simplest ratios. So instead of C2H4, what is the simplest ratio between the carbon and the hydrogen? If I divide through by 2, then the empirical formula is CH2. This is what? Ethene. This is an alkene. What was the general formula for alkenes? Remember, general formula is CnH2n. You should know the general formula for alkane and alkenes. This is an alkene. The general formula is CnH2n. Ethene is a member of the homologous series of alkenes. All members of the same homologous series have the same general formula. So he already mentioned that they have the same general formula. Now give 2 other characteristics of a homologous series. We said members of the same homologous series should have the same general formula and the same what? The same functional group and the same chemical properties or similar chemical properties. Ethene is used to make polyethene. What is the type of polymerization when we start with ethene? This is addition polymerization. Complete the equation for polymerization of ethene. Now, if I'm starting with ethene and I want to draw the polymer, we said, how do we draw the polymer? The 2 carbons that have the double bond. I copy them, but with a single bond. So I remove the double bond, I make it single bond, and then I put a new bond on the right and a new bond on the left to join this unit to other monomers to form a long chain. I'm starting with n numbers of ethene, so I should have a polymer that has n of these repeated n times. Okay, so you need a small n outside the bracket. Polyethylene is used to make plastic bags. Cornstarch from plants can also be used to make polymers for plastic bags. The table gives some information about polyethylene and the polymers made from cornstarch. So if we're comparing the polymer from ethene and the polymer from cornstarch, well, which one is cheaper? Actually, the polyethylene is cheaper. Which one is stronger? The polyethylene is stronger. Which one takes time to decompose? Well, the polyethylene will take a long time to decompose as compared to the polymer from cornstarch. Now, use the information in the table and your knowledge to discuss advantages and disadvantages of using polyethylene to make plastic bags. So, what are advantages of using polyethylene? Well, the advantages would be the fact that polyethylene is cheaper. That's what we got from the table. It is stronger and it does not need to use up crops. So he's saying the other one, I need to get it from cornstarch. That means I need to use agricultural land to plant corn and then take the cornstarch and make polymers. So the polyethylene has an advantage that I don't need to do that. The disadvantages of polyethylene, of course, we know that polyethylene is obtained from crude oil, which is non-renewable resource. We know also that it is non-biodegradable, and that's why it takes a long time to decompose. So it is non-biodegradable, so accumulates in dump sites, and if we try to burn it, it releases toxic gases. The diagram shows the repeat unit of another polymer. Now draw the displayed formula of the monomer. Now if he gives me the diagram of the polymer, what is the monomer? Or what is the structure of the monomer? Remember, we just take away, remove that bond on the right and the bond on the left, and we put a double bond in the middle. Now keep everything else the same so that you do not get confused. So just look at the two carbons that have bonds on both sides, on left and right. Remove the bonds on the left and the right and put a double bond in the middle and just copy everything exactly as it is. And remember that he wants displayed formula, so you have to show all the bonds. This question is about carbon and its compounds, and he's saying draw a dot and cross diagram to show the outer shell electrons in a molecule of carbon dioxide. How do we draw dot and cross of carbon dioxide? Well, you should know oxygen has 6 electrons in its outer shell. It's in group 6. So it needs 2 from the carbon. So it's going to give 2 to the carbon and take 2 from the carbon. So they're going to share 2 pairs of electrons. The oxygen on the other end is the same. Now the carbon had 4 of its own, so it needs 4. So it's going to share 2 with the oxygen on this side and 2 with the oxygen on the other side. So everyone now is complete. The atoms in carbon dioxide are held together by covalent bonds. Describe the forces of attraction in a covalent bond. We said when we have a covalent bond, what happens? There is a strong attraction force between what? Between the bonding pair of electrons or the shared pair of electrons and the positive nuclei of the atoms. Remember, they are the positive nuclei of both atoms that are sharing the electrons. The diagram shows 3 different structures of carbon. So we have diamond, graphite, and fullerene. Explain why graphite conducts electricity. Remember that graphite conducts electricity because it has delocalized electrons that are free to move. Now, explain why diamond has a much higher melting point than fullerene. Remember, Diamond has what kind of structure and what kind of bonding? Diamond has giant three-dimensional structure with strong covalent bonds that need a lot of energy to be broken. While the fullerene or anything that he says has low melting point, that would have a low melting point because it has simple molecular structure with weak attraction forces between the molecules that need a small amount of energy to be broken. This question is about reduction of metal oxides. Solid oxides of copper can be reduced by reacting them with methane gas. Complete the equation for the reaction between copper oxide and methane and include the state symbols. So let's start with the state symbols. He says up there that oxides of copper are solid, and we should know that copper oxide is a solid, methane is a gas, copper is a metal, of course, so it's a solid, carbon dioxide is a gas, and water is a liquid. Now we need to balance. So what do we have? We have 4 hydrogens before the arrow, so I need 2 in front of the water to make it 4 hydrogens after the arrow. That means now I have how many oxygens after the arrow? I have 2 from the CO2 and 2 in the water, so we have 4. So I need 4 in front of the CuO, and that means now I have 4 copper, so that will make 4 copper after the arrow. Now, everything else is balanced. We should check before moving on. So all of this now is balanced. A teacher uses this apparatus to demonstrate the reaction between a different oxide of copper and methane gas. So he has an oxide of copper and methane gas. The teacher heats the oxide of copper until the reaction is complete, and he has these results. Use the teacher's results to show that the empirical formula of this oxide is Cu2O. So how do we do that? The first thing, we get mass of copper and mass of oxygen. So how do we get mass of copper? Mass of copper is the difference between the weighing boat plus copper and the weighing boat alone. What about mass of oxygen? Mass of oxygen is the weighing boat plus the oxide minus the weighing boat plus copper alone. So now we have mass of copper and mass of oxygen, and we try to get the empirical formula. So we divide each of these by the atomic mass, we get numbers, we divide them by the smallest. This gives me a ratio of 2 to 1, so the empirical formula is Cu2O. Then he says the teacher wears safety glasses and the lab coat during the demonstration. Give one other safety precaution that she should take. Remember, we were using methane gas, and any experiment that uses a gas or produces a gas should be done in a fume cupboard. So we say do the experiment in a fume cupboard. Iron forms when iron 3 oxide is heated with carbon. The equation for the reaction is this. State how this equation shows that iron 3 oxide is reduced. Why do we say that the iron 3 oxide is reduced? Because it has lost oxygen. State why carbon monoxide should not be released into the atmosphere. You should remember, carbon monoxide, what is the hazard or what's bad about it? It is toxic. If he says why it is toxic, remember, it is because it reduces the capacity of blood to carry oxygen. Calculate the maximum mass in tons of iron that can be produced when 30 tons of iron 3 oxide are reacted with excess carbon. So this was the equation. And he wants the maximum mass of iron when we start with 30 tons of iron 3 oxide. Remember that we cannot work with tons. We have to change it to grams. And he tells me that 1 ton is 10 to the 6 grams. So what's the first thing we should do? He gives me information about iron 3 oxide. I should get the number of moles of the iron 3 oxide, so I need the MR of the iron 3 oxide. Of course, we know how to get MR. MR is the atomic mass times how many? So atomic mass of iron times 2 plus atomic mass of oxygen times 3. So MR of Fe2O3 is 160. Now we need number of moles. Number of moles is mass over molecular mass. So the mass that he gives me, but I have to change it to grams. So I have to multiply by 10 to the 6 over the MR. This gives me number of moles. So this is the number of moles of Fe2O3, but he's asking about what? He's asking about iron. The equation shows me that 1 mole of Fe2O3 gives 2 moles of iron. So the number of moles of iron is that times 2. Then I can get, what does he want? He wants mass. So mass is number of moles times MR. This would give me the mass in grams, but he wants the mass in tons. So I need to divide by 10 to the 6. So this gives me 21 tons. A mixture of 25,000 moles of iron 3 oxide and 840,000 grams of carbon is heated. Use this equation to show that in this case the iron 3 oxide is excess. So in order to know that iron 3 oxide is excess, I need to get the number of moles of carbon. So he says I have 840,000 grams, so the number of moles of carbon will be the mass over the molecular mass of carbon. So this gives me this number of moles. And then I look at the equation and I compare it. Now, if I have this number of moles of carbon, then the number of moles that of Fe2O3 that I need would be that divided by 3. So I need 23,333 moles. But what did he add? He added 25,000. So the amount of Fe2O3 that I need is less than what he added, and that means that what he added is excess. And that's the end of this paper. I hope this was useful to you. Thank you for listening.